We've already seen a video of graphing transformations or transformations of functions, looking at them graphically. Let's look at it again with absolute values, since that's our new section. Recall, anything inside the parentheses, in this case, these grouping symbols, which are the absolute value bars. Similarly, we have other grouping symbols would be radicals, or the square root symbol, the parentheses, brackets, sometimes braces, fractions, arguments of other functions like log, natural log, sine, cosine, tangent, other trigonometric functions, but also absolute values. Whatever's inside these bars is going to shift it in the x direction, and it's the opposite of what we might seem. So this -2 is going to shift our function to the right 2. Outside the function, this -4 is going to go affect the y direction. So it's going to go the direction that we would think it should go. This negative says it's going to go down 4. And so we're going to graph this. We're going to graph this accordingly. Now our parent function is absolute value of x. This is y equals absolute value of x. That's our parent function. So what are we doing? We're shifting it to the right 2, and we're shifting it down 4. So the origin here is going to the right 2, and it is going 2, 3, 4, down 4. Everything else remains the same. This is y equals absolute value of x minus 2 minus 4. Looking at our next function, f of x equals -2 times the absolute value of x minus 1. Similarly, this is going to shift it down 1 because it's outside the grouping symbols, or the absolute value bar. This is also outside, but it's a constant. It's multiplied out front. So this 2 affects the y values, but it's multiplying all the y values by 2. So if we had an xy tree where with x and y being -2 is 2, -1 is 1, 0 is 0, 1 is 1, 2 is 2. That's for our absolute value of x. But if we do the 2 times the absolute value of x, whatever we put in for x, -2, instead of having 2, it's going to be double that. It's going to be 4. -1, instead of being 1, it's going to be double that. It's going to be 2. 0 is still 0. 1 is 2. 2 is 4. So graphing this, we said it's just steeper. It's going to stretch this by a factor of 2. The negative out front flips it over the y-axis because the negative is outside the grouping symbols. It affects the y values. So if we have this negative, all of the y values now are all opposite. Graphing that from our parent function, it's the same yellow one. We're shifting it. We're going to stretch it 2 in the y direction. We're going to flip it over the x-axis, and then we're going to shift it down 1. So it's going to look about like this, where at this point would be 2, -4. We would have -1, -2. Our last example, f of x equals the absolute value of 3x plus 1, is graphed similarly. Inside the grouping symbols, or the absolute value bars, there's a +1, so we're going to move it to the left 1 spot. Now, if we looked at an xy tree again of this, if we have x and let's just say 3x, -2 is going to be, well, the absolute value of 3x. -2 is, -2 times 3 is -6. The absolute value of that is +6. -1 is going to be a +3. 0 is going to be 0. 1 is going to be 3, and so on. So again, it is going to expand this in the vertical direction by a factor of 3. It's going to stretch this. So let's go ahead and graph this. Let's, from our parent function, move to the left one place, and then we're going to graph this just like an absolute value symbol, but this time it crosses the y-axis at 3, having been shifted to the left one spot.